Okay, this is question number 13 from homework set day 4 of Unit 8, Lesson 3. And this question asks us to use algebraic reasoning and the inverse tangent function to find all solutions for the following equations, give exact solutions if possible. So we're going to start off with part A. Part A says to solve the tangent of x is equivalent to 1. So a couple things to reference here. If we were to use the arctangent, the inverse tangent to this problem, I would say the inverse tangent of 1 is equivalent to x. I'm going to go ahead and reference this on my calculator for a moment. I'm in degree mode, so what I'm going to do is take the arctangent of 1, and it pops out 45 degrees. Okay. Now this does not say to use radians, so I could stick to degrees, but I'm going to do this in two pieces. I'm going to write out my 45 degrees, so I know x is equal to 45 degrees, or I'm going to write out my answer as x equals pi over 4 radians. Now, a couple things. It says to list all solutions for the following equations. If I reference the equation graph for tangent, tangent was that one that did something slightly different. It had this kind of almost cubic looking feel to it, right? And we kind of had these issues where it's undefined for certain values. It was undefined when the cosine would be equal to 0. So it was undefined for pi over 2 or 90 degrees, depending how you want to look at the graph. And then it was, again, a problem at 3 pi over 2, which was 270 degrees. And so every really odd multiple of pi over 2, we had this undefined tangent, right? However, we want to know where the tangent equals 1. And so the 1 is going to have to occur at very nice value, which is actually pi over 4. So it shows up right here at pi over 4, but then again here, then again here. Now another big difference about tangent is that a period on tangent is not 2 pi, right? A period on tangent is actually just pi. It's half as big. So the period is only pi on these. So what we have for solutions are x equals 45 degrees plus, well, pi radians is also 180 degrees, so go 180 degree n. Or I could write my solution out in terms of the radians as pi over 4 plus pi n. But in both these cases, n is an integer. So a slightly different feel to the tangent function only because it has one solution per period. Periods are shorter. They're only pi, not 2 pi. So there is A. Let's go to B. B says let's find the inverse tangent. Whoops, I'm looking at the wrong problem. 13b actually says the 5 tangent of x equals 1. So in this case, I'll divide by 5 first, which will leave the tangent of x equals 1/5. Now 1/5 does not ring a bell for any special angles, so I am going to jump right to my calculator in this case and do an inverse tangent of 1/5. I'm going to leave that in degrees to begin with, okay? So this inverse tangent of 1/5 equals 11.3099 degrees, or let's put that in radians too. So I'm going to switch my document settings over to be in radians this time, and make that default. And I'm going to hit enter just to get the answer in radians. That's 0.1973. We'll go to 3 decimal places, so 0.197. So right, my solution is this. X equals 11.3099 degrees plus 180 degrees n, or x is equivalent to the 0.197 plus pi n, and again, n is an integer. Okay, let's do the last part. C. C says the 5 tangent of x minus 1 equals 19. So again, the x minus 1 piece is not inside the tangent x's, so we'll add 1 first. That leaves that the tangent of x equals, 5 tangents of x equals 20. Divide by 5 on both sides. I find that the tangent of x equals 4. Now that's interesting because if this was a cosine or a sine problem, 4 is outside of the range of the sine or cosine functions. It's not outside the range of the tangent function. Tangent allows us to go to infinitely large negative and positive numbers. So I can solve this using inverse tangent, which I will have to do. Inverse tangent of 4 will equal x. So let's do that. Inverse tangent of 4 gives 1.32. Let's make sure I reference this right. 1.32, and I'm going to make that a 6 as an approximation for radians. Or if I do this in degrees, I could convert, of course. And since I have been doing both, I think I will. Let's go back then to settings and status and change this back to degree. Okay, and I'll hit enter again. And it's 75 degrees, or x equals 75.964 degrees to make that appropriate. So I'll write my solutions as x is equivalent to 1.326 plus pi n, or x is equivalent to 75.964 degrees plus 180 degrees n. And again, where n is an integer. And that will end this problem.